The function game.
It's a mystery for you to work out.
Guess the rule. So Caroline's going to give me a number, and it's going to be the input to the function, and I'm going to, there's the input to the function, and I'm going to give the output. Now the function is a rule, like if you put in a number, out comes 3 times that number. Or if you put in a number, out comes a half that number. Or if you put in a number, out comes 5 times that number minus 7. So there are many functions, and the challenge is, can you guess the function? Okay, and you can make it very simple for younger learners, and you can make it quite challenging for older learners who are a bit more confident. All right, Caroline, give me a number.
A number. Let me start with the number 1.
With number 1, all right. And the input's 1 and the output is 4.
Okay, let's see if it's times 4 or add 4. Let's do the number 2. I should be saying quiet, shouldn't I? Not saying, telling you my guesses. Okay. All right, let's go for the number 10. Ooh, I think I've got a guess.
All right, I will give you an output.
Right.
And you have to give me the input.
Okay. Ooh, right. I think I've got to get it right. Oh dear. Is the input 15?
Yes, well done. Caroline, I gave you the output of 46, and you worked out that the input was 15. How did you work that out?
The first 2 steps I was a bit puzzled because I wasn't quite sure how you got 4 from 1 and 7 from 2. But when you went to 31 from 10, I learned a trick that you taught me, which was it's about how many times bigger, and it's 3 times bigger, and then it's only 1 more. So I thought, okay, so it's 3 times that plus 1, and I tested it with these 2, and those were also 3 times that number plus 1.
And so how did you get 15?
So the last thing I did was add 1. So the first thing I had to do was take away 1. So that was 45. And then I have to say, even though I know perfectly well what 3 times 15 is, it did take me a little bit to actually work out what 45 divided by 3 was. My mind did a
But
flip.
you did it.
I'd managed it, but it was a nice challenge.
So we haven't been talking algebra yet, but this is essentially algebra. Let's say we want to note what happened, make a record of what happened. What was this function? How did it? What's the rule? Write it down. Well,
you were saying earlier this is nice introduction to algebra.
It is, and it makes it seem convenient because we want to write it down. How are we going to write it?
Yeah, you really want to write. I actually want to see this written down rather than see an A and a B and go, what's that? Or an X and go, what's that? This I actually want to see written down because I've got a vested interest in it.
Let's look at this function. So what we did was we multiplied it by 3. 3 2s are 6, and then we added 1. So we multiplied by 3, and then we added 1. And that's a good way to start. Notice it's only words. Well, we've written it down as times 3 plus 1, but what did we multiply by 3? Now,
these numbers.
Yes, but there are lots of different ones, and each time we multiplied the input, by 3. Now, what we're putting in is something called n, which could be any number.
So n is any number. We're going to call it n, and it's any number. Any number that's in the input box at this point.
And then the rule is actually written here. The rule is in a way that we can read it and understand what the rule is. So it's, what did we multiply it
So
by?
3 times n,
n,
right?
3
We're calling
times
that n.
n plus 1.
Right.
Now, it's just so we know, which do we, if we just saw that, we'd be thinking, well, what do we do first? Do we multiply or add? Well, we should know that we should multiply first, but let's just make it absolutely clear. And this is what everybody who's doing mathematics knows, that we don't need to write that multiply down. And when we write 3n, we mean 3 times n.
So 3n means 3 times n. And so if you see an x somewhere and you see 2x, it means 2 times x.
Exactly.
Okay.
And so this is 3n plus 1, and that's the function. It's the function rule written so that you can read it, and it's not scary algebra. We're not going to make any process with it. We're just going to, at this stage, leave it at that.
And the thing is, you could start simply with the times table, and they've got to work out which, they've got a spot that you're just doing. You don't have to do any adding to the very, very beginning. You can just use a timetable that they know, and they can work out which the times table is, for example. Or you just be adding a number or taking away a number.
Now, what you did was gave me 15 when I said, well, look what's happened to give an output of 46. So that's coming back this way. These arrows are going that way. So the function is taking the number that's the input, doing something with it, and giving an output.
Okay.
So now then, let's see how we got back. Now we call that the inverse function. Now, an example of that is you put on your socks and shoes, and you do it in that order.
Right. Yeah, you can't put your shoes on before your socks.
Well, you don't usually.
Well, you don't usually, but it'd be quite difficult. You'd have to have very big socks. It wouldn't be your socks. It'd be somebody else's
Well, they'd wear
socks.
out, wouldn't they? But what you can't do is take your socks off before you take your shoes off.
Yes.
So you put your socks on first and then your shoes. When you're going that way and coming back this way, you take your shoes off before you take your socks off. So let's see what we do here.
So the first thing we have to do, the last thing we did was add 1. So now we're going to take away 1 first before we do anything else.
Yes. So
are we going to call this n as well? It doesn't matter if it's
n just is any number.
Any number. So it's still going to be n. So we start, this is n. So from n, we're going to take away 1.
Right. So we'll say n, take away 1.
And then we're going to divide all of that by 3.
Divided by 3. Well,
is it not all of that?
Exactly. So we need to use brackets, or to make it a little bit clearer, we write n take away 1 over 3 like that.
Right. And that's where all of that came in. Nice. Okay.
Yes, this is a flow chart.
A flow chart,
yes. And that's a very, very useful device for planning. And indeed, it's a tool. The flow chart is a tool that computer programmers use.
Yes.
This is a bit simpler because we're just looking at a few operations where every input has an output. So we are sure that we're going to get an answer each time. Okay, and what I haven't done is shown that for the inverse function, the flow is that.
Oh, that's important.
Yes.
Yes.
So this summarizes what's happening, and with this rule, and then change the rule to something else and do it again.
You can just do addition and subtraction, and they're the inverse functions of each other.
Indeed.
So it's just a really nice way of introducing more complex ideas.
And this